Okay, today we're continuing our discussion on our sets of numbers, and we're going to talk about the set of irrational numbers. And the set of irrational numbers is the set of numbers whose decimal representations are neither terminating, which means they stop, or repeating. Okay, irrational numbers, some people also like to think of them, if you remember when we talked about rational numbers are any numbers that can be written as a ratio of two integers. So irrational numbers are those that cannot be written as a ratio of two integers. But sometimes it's easier to think about them as those decimals that neither terminate nor repeat. So some examples of that, any radical that cannot be simplified to a whole number, the square root of 2. You also, uh, a decimal that doesn't repeat. You could have 1, 0, 1, 1, 0, 1, 1, 1, 0. Now you might think that this decimal is repeating, and what really is, it has a pattern, but it does not repeat. It doesn't have anything that we can put a bar over it that it would look like the same thing over and over and over again. Okay. Other irrational numbers that you might be familiar with, pi, and Euler's number e. Those are also irrational numbers. Okay. So what we're going to work on today are simplifying radical numbers and operations with those. These radical numbers deal with perfect squares because that's how we come out of the radical. So remember that perfect squares are numbers that are squares of whole numbers. So I have a list here that you need to be familiar with. That's what's going to help you simplify your radicals. So I gave the first 15 whole numbers, and we're going to square them. 0 squared, 1 squared is 1, 2 squared is 4, 3 squared is 9. Remember, when you square a number, you're multiplying it by itself. So 4 times 4, 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. Then we have 8 squared, which is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196, and 15 squared is 225. So those are numbers we're going to be working with, so they should be very familiar to you, and keep them in your head as much as possible. Okay, so we have two rules that we need to be aware of in our operations with square roots. One is our product rule, okay, that tells you if you have the square root of a product, that's equal to the product of the square roots. So if I have them multiplied together underneath, then I can separate them. And I can go the other way. Okay? The product of the square roots is equal to the square root of the product. And in a similar fashion, we have our quotient rule that's going to say the square root of a quotient is equal to the quotient of the square roots. Keep in mind, of course, that b cannot be 0 because we cannot divide by 0. And the quotient of the square roots is equal to the square root of the quotient. So I can go back and forth whatever I need to use to simplify my radicals. Okay, so as I talked about, you need to be familiar with these numbers. The square root of 16 is 4. The square root of 49 is 7. That's going just back on my list. The square root of 100 is 10. The square root of 144 is 12. The square root of 225 is 15. So you need to know where that button is on your calculator if you don't know what those squares are without. Okay, sometimes, okay, and this is really the gist of what we're talking about here, that these numbers here, you have to use a calculator, or you're going to use a calculator to find the square root of them because they don't come out to a nice, neat whole number. So they're not perfect squares. So number 30, the square root of 3176. Okay, keep in mind, some of y'all have a calculator that when you put that in the calculator, it's going to come back out at you and say that that is equal to 2 square roots of 794. Now we're going to talk about that in a minute, but that's not what they asked for here. They asked for the decimal approximation. So you got to find that button on your calculator that puts that into a decimal for you. And the first part is we're supposed to round that to the nearest tenth. So to the nearest tenth, you have 56.4. To the nearest hundredth, it's going to give you 56.36. And to the nearest thousandth is going to give you 56.356. So these are the answers to that problem. Okay, similar to number 32, but skip down to number 34. Okay, the square root of 2 pi. So make sure you know how to put that in your calculator. And when you bring it out to the tenths, you should have 2.5. To the nearest hundredth is going to be 2.51. And to the nearest thousandth is going to be 2.507. Again, you should be putting them in your calculator and making sure that you know how to do these problems and how to use your calculator. Okay, so the next set of problems, we're going to talk about simplifying the square root. Okay, when we simplify, what you want to do is look for the largest perfect square that is a factor. Okay, um, let me review some terms down here. I put it down here. Um, we have an expression looking like the square root of 15 right here. Okay, in the square root of 15, the actual symbol here, I don't want to come up, that little, the thing that looks like a check mark or division symbol, that's actually referred to as the radical sign. Okay, what's underneath is called our radicand, and the whole thing is called your radical. Okay, so we are simplifying these square roots or simplifying the radical. Okay, and we are looking for the largest perfect square that's a factor of the radicand. That's the number underneath. So I have a list of our perfect squares that we just put on the other page. And I'm looking for the largest one of these that would go into 50. So obviously I don't need to look at any number higher than 50. And hopefully you can see that 25 is a factor of 50. So 50 is equal to the square root of 25 times 2. And as we just saw before, on the page before with our products, that's the square root of 25 times the square root of 2, or the square root of 25 is 5, so we have 5 square roots of 2. Okay? Now, I'm going to do another one, and I'm going to talk to you about your calculators. 12, okay, the largest perfect square factor that goes into 12 would be 4, so it's 4 times 3. Okay? When you simplify, you don't have to write this step anymore. You can just say the square root of 4 is 2, so we can bring that out, and our answer would be 2 square roots of 3. Okay, this is a minimal step that you need to write on your problems, this right here, because we have some people that have calculators that will actually, don't do that to me. They have calculators that will do the problem for them. Okay, your calculator, if you put in the square root of 12, is going to give you back 2 square roots of 3. Okay, you got to show me a middle step to give me full credit, to get full credit for the problem. Okay, 192. All right, I'm looking for 4, 9. If I try 16, 16 goes into 192 um, 12 times. Now, 12 has a number in there, but if you want to go ahead and start with 16, you can. So if I say that's 16 times 12, then I know that that is 4 times the square root of 12. Well, I just did the square root of 12 up here. So that is 4 times 2 square roots of 3. So that's going to give me 8 square roots of 3. Whatever's on the outside of the radical, you combine. Whatever's on the inside, you can combine. Okay? 3 square roots of 52. So I have a 3 that's going to stay on the outside. 52, I'm looking for the largest factor that goes into it. 4 happens to be it because 52 is 4 times 13. And the square root of 4, so I'm carrying the 3 outside. The square root of 4 is 2, so I get to bring that out. And then I have the square root of 13 because that's not a perfect square and none of these factors go into it. So multiply your outside numbers. That gives you 6 square roots of 13. Okay, as I work through these last group of problems, there are a lot of them, as you can see. I encourage you to pause, work the similar problems that are in the homework, and then pick back up again. So don't sit here and watch all of them at the same time. I want to do lots of examples so as you go through the problems in your classwork, then you have lots to look at. Okay? So, as we have talked about, when you go through square root of 19 times the square root of 3, we're um, always going to simplify our answers. And when we simplify our answers, that means that there are no factors that are perfect squares that are part of the radicand. Remember that radicand is the part underneath. So none of these numbers will be, or as they get higher, would be factors of that. When you look, 3 and 19, if you remember from our last section and know that those two are both prime numbers, then the only way to simplify it is to go ahead and multiply them. So 3 times 19 is the square root of 57. Okay? The square root of 5 times the square root of 5. You can multiply it out, but one of the things that you really want to remember is that the square root of x times the square root of x equals x. So this would be the type of problem that I don't care if you write a middle step. The square root of 5 times the square root of 5 is that radicand that's underneath. So it's 5. If you go the long way and multiply it out, it's the square root of 25. What's the square root of 25? It's 5. So just keep that in mind as you go through. Okay, the square root of 12 times the square root of 2. Remember, they can all be written underneath the same radical. And in that aspect, I want to find if 2 goes into 12, which it does. So I'm going to write it as 6 times 2. And there's the 2 that was this one right here. Anytime you see 2 of the same factors, it's this concept. So that means that I can bring that 2 out and what's left underneath is 6, which there are no perfect square factors of 6. So that's my final answer. Okay, square root of 5 times the square root of 50. Okay, do I have 5 that goes into 50? I do, 10 times. So that means I can bring out my 5 and have 5 square roots of 10 as my final answer. Okay, so those of y'all who have the calculator that would do this for you, you've got to show me some kind of middle step like this if you want to receive full credit for the problem. Okay, those, there's no middle step, you're fine. But any of these others, you're going to see there will be a middle step that I will write, and I expect you to do the same when you do your homework and when you take your test. Okay, so the square root of 75 over the square root of 3, when you have something like this, bring it together. That's the square root of 75 over 3. And 75 divided by 3 is 25. And the square root of 25 is 5. Okay? Number 54. The square root of 60 over the square root of 3. Okay? That's 60 over 3. 60 divided by 3 is 20. Okay? So now I'm looking for the perfect squares that are factors of 20. And 4 would be the largest one. 4 times 5 is 20. The square root of 4 is 2. So we have 2 square roots of 5. Okay? The negative sign, we've dealt with that before. If you've got a negative here, it's going to be a negative in your answer. So I can keep that outside. 150 over 3, which is 450, it's the square root of 50. Okay? And you can go straight from here to here. I'm okay with that. But from here, I would need to see, again, I'm carrying the negative, that 50 is 25 times 2. Now notice that's different than what I wrote up here because I was looking for one that was already a factor of 5. But when I have just 50 by itself, 25 times 2, the square root of 25 is 5. So we have negative 5 square roots of 2. Okay, so that's multiplying and dividing, simplifying as we go along. The last group that we're going to work on is adding and subtracting. Okay, in adding and subtracting, you want to think about adding and subtracting like terms. Okay, if you have 8x plus 5x, then you know that you're just going to combine 8 and 5 to get 13. Your x stays the same. The radicands must be exactly the same, just like the x's have to be exactly the same to combine your like terms. So when you're starting out, or if you want to use a highlighter to do it, note that this and this have to be the same. So if they are exactly the same, then I just get to add 8 and 11 to get 19 square roots of 5. Okay, so if I go to another one, all right, square root of 17, square root of 17. My radicands are exactly the same, so I'm going to combine the numbers on the outside. That is 6 minus 8, and 6 minus 8 is negative 2. And then I have this blob. Sometimes I refer to it as blob because that's a little easier to say than the square root of 17. Okay, square root of 3 plus the square root of 3. So if we go highlight those radicands so that you can see that, this is the same as this. So if this were an apple and that were an apple, how many apples would I have? Well, I would have 2 apples. So that's going to be 2 square roots of 3. Okay, just like with our variables, you do have a 1 out front there that you don't have to write. Okay, so moving along to this next one. Again, radical, radical. Each each of those radicands is the same. So if each of them is the same, I'm going to do 6 plus 8 minus 16. 14 minus 16 is negative 2, and my blob stays the same as what I highlighted. Okay, now this last set, these are somewhat contrived, so keep that in mind when you do it. Contrived meaning they're designed to help you practice a concept. I cannot combine these two because they're not the same. But can I make this one look like that? And I can. I'm going to carry the problem. Square root of 3. The square root of 27 is 9 times 3. So when I simplify that, I'm going to have the square root of 3, that's this one, carried forward. And then this, the square root of 9 is 3, so this looks like square root of 3 plus the square root of 3, which is 4 square roots of 3. Remember the 1 is in front here. Okay, so this is where I'm saying it's contrived. Divide 3 into that number and most likely you will have a perfect square because they're designed to make you practice. Okay, the square root of 63 and the square root of 28. Okay, if you don't know what goes into them, you're looking at perfect squares. Okay, um, 63 is 9 times 7. So divide 7 into that number and you have 4. So this one is going to be 4 times 7. 9 times 7 becomes 3 square roots of 7. The square root of 4 times 7 is going to be 2 square roots of 7. 3 minus 2, because now my radicands are exactly the same, is going to be the square root of 7. And that's my final answer. Okay, 3 more. If you need to pause, if you're good, go on, and then we're going to be done. Okay? So, again, 4 square roots of 12. So, the 4 stays on the outside. 12 is 4 times 3 plus 2, and 75 is 25 times 3. So I'm going to work down this time. I'm going to do these over there. So the square root of 4 is 2, so this becomes 4 times 2 square roots of 3, plus the square root of 25 is 5, and the 3 has to stay underneath. All right, I wrote the multiplication so you could remember. So it's 4 times 2 is 8 square roots of 3. 2 times 5 is 10 square roots of 3. So when I bring those together, my final answer will be 18 square roots of 3. All right, so this next one, let's go. I'm going to work over here with it. Again, same concept, 1/5. Okay, it's not under my radical, so I can't bring it there. But 300, hopefully you see, is 100 times 3. And then I have 2/3, and 27 we already broke up earlier as 9 times 3. So when I bring it out, I'm going to have 1/5 times the square root of 100, which is 10 square roots of 3, minus 2/3. The square root of 9 is 3, and the other 3 stays inside. 1/5 of 10. Use your calculator. You just took a test on it. Everybody did well. So that gives me 2 square roots of 3. 2/3 of 3 is 2 square roots of 3. And 2 square roots of 3 minus 2 square roots of 3 is 0. When you subtract the same thing you started with. Okay, last problem. Again, I'm looking for, now think about a number that goes into both or find the one that's easiest to break up. But 72 is 36 times 2. 50 is 25 times 2. 128, I'm going to divide that by 2 because I don't know what goes in there immediately, but it's 64 times 2 because I had a 2 left over with a perfect square. So this becomes 2 times 6 square roots of 2 plus 3 times 5 square roots of 2 minus 8 square roots of 2. 6 times 2 is 12 square roots of 2. 3 times 5 is 15 square roots of 2 minus 8 square roots of 2. So all of my radicands are exactly the same, and that means 12 plus 15, which is 27, minus 8 is 19 square roots of 2. Okay, so um, I wrote down what work I would expect to see on your paper. If you need more, please don't hesitate to come up and ask. Um, it's better to write more than less when you're doing your problems. So, if you have any questions, please come see me. Thanks.